Okay, so now we are moving on towards chapter number 3, right? So if we look at chapter 3, there are some questions, which important questions for this year. Uh, Scalars and vectors are given. So if you can see, you can find the difference here in the notes as well about the scalar and vector quantities, right? So you can see there are 4 points of difference between these quantities are written. So you can easily see this. Let me recall this once more, that all those physical quantities which have magnitude only are known as scalar quantities. On the other hand, vector quantities are those quantities which have magnitude and have a specific direction. Means without direction you cannot actually uh, specify or express these physical quantities which are vector quantities. Example can be a force, right, which we know that force is applied to a certain direction. As compared to scalar quantities, we can say time, right? So in time is an example of scalar quantities which we are only interested in magnitude. Like let's say it's what's the time right now, so it's 11, right? So it's 11 a.m. So 11 a.m. is basically the magnitude. So basically this is what makes it a scalar, because it doesn't have any direction. On the other hand, as we have discussed the example of force, force is a vector quantity because it has a uh, direction. Means wherever you're, for example, you're pushing a car, right? So when you're pushing a car, so you're applying certain force in a certain direction, right? So that's makes it a vector quantity. Okay, so this is what the other difference can be, that you can represent a scalar like with a symbol, basic just a symbol, and for vector quantity you can just represent it with an arrow or a cap on that symbol, right? So these are some of the differences, as you can see, and it is mentioned here. As we have discussed, that I will be sharing all these important links for these notes and the past papers and the important questions with you, so that you can practice them at home also. uh, Second question is about the basic definition about kinematics, mechanics, dynamics, distance, displacement, speed, velocity, and acceleration. So these all the definition we have discussed, and you can also in the class, and for making very simpler notes, you can access easily to or refer to these notes as well, right? And in case any confusion you have, you can directly ask from me in the class also, and after the class as well. uh, as you can see, the definition of kinematics, we can find it on the next page. Yes, kinematics, mechanics, dynamics definitions are given here in the notes, right? Another important question which is not mentioned this year, by the way, is the difference between distance and displacement. Again, one is a scalar quantity, another is a vector quantity. So these definitions, you can access them from your book. You can find them in your books, and as well as you can find them here online on from internet, from notes, right? So you have many options. The third question, and a very important question, is about the derivations, the second and third equation of motion, which is mostly the part of the exam every year, you can say, right? So here for this, let me show them how to work them out. Uh, I will show them how we have derived these equations shortly. Secondly, you can see here also in the notes also they have mentioned here given these derivation. So you can see this is the third equation of motion which they have derived. Secondly, there is another which is the second equation of motion. You can see this equation, they have derived it. And I will shortly show you how they have worked out these derivations here on the board as well. Okay, moving on towards the whiteboard, let's use the whiteboard from the same Zoom software. Okay, now you can see now all the students, you will be seeing this whiteboard in front of you, the screen, right? So we will start here from the first equation, and the first equation is Vf, which is representing final velocity, equals to Vi, which is representing initial velocity, plus At. Now A and T, as you can see, there is no symbol between them, so they are multiplying actually according to simple mathematical rules. And A is representing here the acceleration in the equation, and T is representing time. So let's start deriving this first derivation. We know that there is a formula of acceleration, which is A is equals to Vf, which is again final velocity, minus Vi upon time. Now if we rearrange this equation, like you know that when we will take this symbol here from denominator to this side, it will be multiplying there. So it will become 80, and this has become Vf minus Vi equals to 80, right? So if you will rearrange this equation, because remember you have to convert this equation into this form, right? So you can convert it in this form by simply applying mathematical rules. So we know that this thing, which is minus Vi, we have to take this thing from this side and replace it here on the left side of the equation, right? So when we will take this Vi, negative Vi on the other side, it will become positive Vi. So it has become Vi plus At equals to Vf, right? So this is the first equation that we have derived for you, right? So this is the first equation of motion. As you can see, we have worked it out very easily, and similarly you can see this is how they have explained here in the notes as well, right? So this is how they are deriving here, right? So you can see this is the derivation of first equation from the notes as well, and similarly we have done it here on our whiteboard as well. Okay, so after that, let's move on towards the second equation of motion. We are done with the first. Okay, so when we go for the deriving the second equation, remember. Okay, now we are starting second equation. Now we know that from a very simple formula that displacement is equals to velocity multiplied by time, right? Well, let me just change this line width. Okay, this one is fine. Okay, so here we are taking this average velocity. Why we are taking average velocity rather than simple velocity? Because we are dealing with two velocities here, which means we have initial velocity and final velocity. So this is the simple formula of displacement, but here we are using the average velocity. So S, which is representing displacement, symbol for displacement, and the average velocity will be equals to Vf plus Vi upon 2 multiply by time, right? So now this is, in place of average velocity, we have written its formula, which is Vf plus Vi divided by 2. Now in the second step, what we are going to do, we are going to replace the value of Vf from the equation. Since we have derived the formula of Vf, you can see it here. The Vf will be, can be replaced with its formula Vi plus At divided by 2, and from here we have this Vi as well, times or multiply it with time. Okay, so if you can see here in the equation, we have two Vi. One is here, another one is here. So we know that Vi plus Vi, it will become 2Vi plus At divided by 2 and multiply it with, you have to, don't forget to use brackets, multiply it with time. Okay. Okay, so further if we solve this, so this will become 2Vi divided by 2 plus At divided by 2, right? So 2 is in whole divide, so we can divide from here, and don't forget again to use the brackets, times it or multiply with time. So we know that 2 is here both in numerator and denominator, so will be cancelled. Okay, further we can start here. uh, so when we cancel this thing, like 2 on both numerator and denominator, what equation we are left up with now? We are left up with Vi plus At upon 2, and again we are using brackets because t is multiplying here with all the brackets. Okay, so when the t will multiply here with all the equations, so it will become Vit plus At square, because t when multiplied with t, simple mathematics, that will become t square. So now this is the formula of second equation that we have derived, right? So here on the screen you can see we have different, we have couple of equations now. This is first equation that we have worked, we have derived, and this one is the second equation that we have just derived, right? So in the guest papers also, if we can see again, they have mentioned that the, if you can see again the question number 3, they are saying the important questions are second equation of motion and third equation. So second equation we have just derived here, if you can see closely, right? So this is the second equation of motion. uh, Let me also write here that this is first equation that we have derived, and this one is the second equation. Right, so let me also separate them with these lines. First equation, and this one is the second equation, right? These are three portions. Now I need to clear the board actually for driving the third equation. So let me erase the things from the board. I hope you have understood it clearly. Meanwhile, if you have any question, you can ask. Is there any question? Okay, so I think there is no question up till now. So okay, let's move on towards the third one. This is the third equation that we are going to drive now. Okay, for third equation, again, our starting point will be same. Like we will be using the same formula. Okay, let's start third equation now. Third equation, as I told you, that we are starting from the same formula. So S will be equals to V average, which means average velocity, multiply by time. So when we open this formula, which is average velocity, so this will become Vf plus Vi divided by 2 and multiply it with time, right? So as if you remember, in the second equation, what we have replaced in the formula, we have replaced Vf, right? But this time you don't have to replace Vf from the formula. Rather than, we will be replacing the value of t. Okay, so if we know that acceleration is equals to Vf minus Vi upon time. So if you rearrange this equation by simple mathematical rules, so we know that this will become Vf minus Vi divided by A, right? So now you can use this value of time in this equation. So let's put the value here. So it will become Vf plus Vi divided by 2 and multiply by, now we are not going to write t this time, rather than we will be using this equation here which we have derived. So in place of time we will write Vf minus Vi upon A, right? So in the next step we will multiply numerators with numerators and denominator with denominators. So it will become Vf plus Vi divided by 2 and multiply here with Vf minus vi. As you can see, I have multiplied both the numerators together. Same goes with the denominators. We are multiplying 2 with a, right? So this is what we did. Okay, now next what we can do here, let me just, okay, it's not going to work. Okay, now what I'm going to do, I'm going to use a mathematical formula here. Okay, so since we know that now this, if you see the numerator, it has become in a form of a plus b and a minus b, right? So we are considering vf as a and vi as b. So we know that according to this mathematical formula, that a square minus b square is equals to a plus b times a minus b, right? So a plus b, a minus b will be equals to a square minus b square, right? So we are going to write it here that v in place of vf plus vi and vf minus vi, we can simply write vf square minus vi square divided by 2a, right? So when we take this again 2a on this side, so this is going to go and multiply on the left hand side of the equation, so it will become 2as equals to vf square minus vi square, right? So now we are done with this. This is the third equation for you, right? So you can see that very small changes we are making in order to drive two different formula. For the second formula, if you remember, we have replaced the value of vf in the equation initially, and now this time we have changed the value of time in order to get this third equation of motion. So this is the formula basically for the third equation, which says 2as equals to vf square minus vi square, right? So this is the third equation that we have discussed today in the class. So I hope you understand all these three equations. Separately we have covered all these three equations, and if you can see again, if you'll go to the questions again, let me share the screen with you again. So today in today's class we have covered like chapter 1, chapter number 2, chapter 1 and chapter 2, you know that that is most of the theoretical topics, and mostly based on memorization. So you can just memorize the question, and you have already did, as you have mentioned, that you don't have any problem in chapter number 1 and chapter number 2. As I've told you, let me recall it again. The important questions um, from this will be question 1, question 3, question 4 from chapter number 1, and from chapter number 2, the question number 2 again comprises of definition. Question number 3 writes some derived units and the base derived units, symbols and units. So we, you have already memorized the tables of base quantities and derived quantities, and also you know the advantages of SI units, why we use them. Okay. Secondly, as I've told you, very uh, few question comes in chapter number 2, mostly MCQs you will be doing. And let me tell you again from where you can access these multiple choice questions. So let me show you here again that from where you can access these notes. So you can go here and class 10 physics notes, right? So yeah, you can access all these chapters notes. You can see all these 19 chapters are here with all the things like you can say the MCQs are there, right? Multiple choice questions, you can see all of them with the answers as well. You can see the tick is there with every question, which is the answer of that particular MCQ question. And secondly, you can find out some solved numericals as well, theory question and answers, right? So many things you can access from to date. So this was an earlier or the first lecture we are now completing, and so far what target we have set at the start of the class, we have covered it most, covered the most of it. Just few things if you can see in the chapter 3 are remaining, which is again you can see here, if you can see my cursor, that the motion and its types will be the agenda, part of the agenda of the next class. um, Newton laws of motion, third second law of motion will be there, inshallah. And the numericals, right? So the chapter 3 numericals, you know, it is important as anything in for your uh, this year's physics paper board exams, inshallah we will be covering that soon. So yeah, that was it from the class. If you have any query, any problem regarding the lecture, if you couldn't understand anything, we have the WhatsApp group, right? So you can share your queries and doubts. Inshallah we will clear those doubts as well. Okay, so see you then for the next class. Allah Hafiz.